Our team has hypothesis number 9. It suggests that Bennu has experienced surface processing in the form of landslides, impact cratering, and particle ejection sites throughout its history.
We are requesting 2 grams of the Bennu sample for our testing. We will be using X-ray diffraction, electron energy loss spectroscopy, and thermogravimetric analysis.
When using the thermogravimetric analysis tool, we would use 0.5 grams of the Bennu sample that cannot be reused afterwards. We will do this by measuring the change in sample weight that occurred over a time interval when the temperature had a constant rate of change. We would increase the temperature from room temperature to the target temperature. The target temperature would be between 200 and 350 Kelvin.
Another way we're planning on analyzing the returned Bennu samples is through electron energy loss spectroscopy. This analytical technique is the use of the energy distribution of electrons that pass through a thin sample to analyze its content and create images with unique contrast effects. We're using 0.5 grams for this destructive procedure, which will provide essential structural and chemical information about Bennu.
For testing using X-ray diffraction, we will use 1 gram of sample. The sample will not be reusable after testing. The testing will mostly be used to analyze the molecular structure of the crystalline formations in the sample. This will provide information on the electrostatic charging and magnitude of cohesion of the regolith, thus determining the way landslides develop in conjunction with impact events.
X-ray diffraction can be used to determine what kind of matter Bennu has and can help us experience landslides. Through this result, as we can find out what matters Bennu have, that will help us realize what incidence Bennu had, which is related to our team hypothesis.
Electron energy loss spectroscopy can be used to determine the surface history of Bennu. Importantly, if certain materials on the surface of Bennu have changed to impact cratering, this information can be used to lead to conclusions for atmospheric changes.
Thermogravimetric analysis will show how the sample's weight will change when we change the temperature, which can show how Bennu matter will change in the various environments. If we related this test to X-ray diffraction test, we can measure what the environment Bennu looks like these days, which is the main questions of our team hypothesis.